So today we're going to look at lesson 6-7, polygons in the coordinate plane. And your whole goal is to be able to classify a polygon and justify it. So it's not enough just to plot it and look at it and say, oh, it looks like a rectangle. You have to prove it. And so proving a parallelogram, you just need one thing: opposite sides are parallel. Proving a rectangle, you're going to need to prove something from a parallelogram plus something that makes it specifically a rectangle, like 2 sets of opposite sides congruent and 4 right angles, or 2 sets of opposite sides are congruent and the diagonals are congruent. Something that makes it special from a parallelogram that makes it a rectangle. Same thing for a rhombus. So a rhombus, yes, you could prove that all 4 sides are equal, but how do you know it's a rhombus and not a square? So you could prove all 4 sides equal and then prove that you don't have 4 right angles. And then with a square, you could prove all 4 sides are equal and prove that you do have 4 right angles. So there's just some examples of what we're going to do today. And in order to do that, we might need to use any of the following formulas. Okay, so I'm going to have to use one of these 3 formulas here. So we have gone over the distance formula. We've gone over the midpoint formula. My, whoops, wait a minute. My pen that I used to write with is acting up today, and I don't know why, so I apologize. It does not want to recognize my pen. All right, so then, and we've also gone over the slope formula. So we're going to discuss those, but remember, distance formula is purely going to tell you the length from one vertex to another. So distance meaning length. Slope is just going to tell you the rise over the run. You cannot use slope to determine distance. Never can I use slope and say that opposite sides are congruent, ever. Slope is used to say that opposite sides are parallel. Or you can use slope to determine whether you have perpendicular lines or not, which will tell you whether or not you have right angles. So that brings us to parallel and perpendicular lines. So if I have parallel lines, I have the same slope. If I have perpendicular lines, then I have slopes that are opposite, sines, and reciprocals of each other. But not all perpendicular lines have opposites and reciprocals. There is one specific set of lines that does not. And so, let's see. Nope. I'm trying to choose my color. So I'm going to draw a perfectly vertical and a perfectly horizontal line. Okay, I hate this pen. I'm going to find another one, so just a minute. All right, so let me try this one, see if this one works better. All right, so, oh, that's much better. May not be a perfectly horizontal line, but we get the idea. Okay, so for this line right here, that is a vertical line. And vertical lines are equivalent to a wall. If you can't walk up a wall, then this line does not have slope. And none of us can walk up a line or a wall without help unless you're Spider-Man. So therefore, this does not have a slope, but you can't say no slope. The slope is undefined. And for it to have an undefined slope, you might want to add this here. That means that in the rise over run for slope, the denominator is 0. Then this right here is your horizontal line. So a horizontal line would be like the floor. We can actually walk on the floor without assistance. And generally the floor in the classroom, for instance, has no incline. So but because I can walk on it, it physically has a slope. So the slope of all horizontal lines is going to be 0. You might want to add here that it's 0 because in the rise over run for slope, the rise is 0. Okay, so if I can prove that I have perfectly vertical or horizontal lines with slopes of undefined versus 0, those are perpendicular lines. Or if I have lines that are at a diagonal like these ones, I want to have opposite signs and reciprocals. So the perpendicular slope to 2/3 would be the opposite sign of negative, and then flip it 3/2. If you multiply the slopes together, they should give you -1. Okay, so let's go through. There's lunch. All right, so let's go through these three formulas just so that you know how to use them. So the first one that we're going to do is going to be distance. And the first thing I'd like to do is label these points as x sub 1, y sub 1, and x sub 2, y sub 2. It doesn't matter which is sub 1 and which is sub 2. And then you have the slope formulas above. So I'm not going to rewrite them, but I'm just going to write the template. And what I mean by that is when I write the distance formula, I'm going to write everything except for the x's and y's. I'm going to write all the operation symbols. Okay, so the only thing I removed were the x's and y's. And so I want to put x sub 1 here, and then I want to put x sub 2 here. So I'm going to do 4 for x sub 1 and -2 for x sub 2. So I'm subbing in 4 for x sub 1 and then -2 for x sub 2. And then for my y's, my y sub 1 is 3 and my y sub 2 is -1. So those go in the next slot. So 3 and -1. And then we're just going to do the math. So our distance, I want to take care of my double negatives. So my double negatives become a plus plus, or you can just do one big plus when you have double negatives. Either one works. And so 4 plus 2 is 6 squared. And then 3 plus 1 is 4 squared. So 6 squared is 36. 4 squared is 16, and if you add those together, you get 52. If you can simplify it, you need to. So I am going to prime factor my numbers. So the numbers that multiply to give me 52 might be 4 and 13, and then 4 is 2 and 2. So because I'm doing a square root and the index is understood right here to be a 2, I'm going to find groups of 2. So I have 2 groups of 2. So I'm going to circle the 2, and so that means 1, 2 comes out in front. And then that 13 doesn't have a pair, so it stays underneath. So 2 radical 13. All right, then we're going to find the distance. We're going to find the slope. So hopefully this green shows up. But for slope, I'm going to rewrite the formula, but remove the x's and y's. So according to the formula, we are going to do y sub 1 minus y sub 2. So you always do your difference between your y's up top and the difference between your x's in the denominator, the bottom. And so you can do 0.1 vertical here and 0.2 vertical here, or you could start with 0.2 and then do 0.1. I'm just going to follow what the formula says and sub in those values. So y sub 1 is 3, and y sub 2 is -1. X sub 1 is 4, and x sub 2 is -2. And as you can see, this is 0.1 vertical to itself, and this is 0.2 vertical to itself. What you don't want to see is them diagonal to each other. You cannot have the points diagonal. Then I'm going to take care of all the double signs. So plus, 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 plus. And then I get 3 plus 1 is 4. 4 plus 2 is 6. And that can be reduced. 2 can divide into both of these. So I end up with a slope of 2 over 3. And you could have over here, I'm going to move this, hopefully it'll move well, which it did, good. So over here you can see that they plotted the point -2, 1 here and 4, 3 here. if your points are plotted, instead of running through the slope formula, you could have stair-stepped that slope. And you can see the stair-step occurring right here. So from this point to this point, we happen to put a stair-step above the line. You could have stair-stepped below the line. That's fine too. All of your signs will be the opposites, but it will still simplify down to giving the same answer. So if I rise, and we have to do rise over run, rise is always up or down, run is always right or left. So here I'm going to rise 1, 2, 3, 4. Here's that rise of 4. And the rise is a positive value, so it's positive 4. And then I'm going to run to the right. Running to the right is a positive direction, so I've got 1, 2, 3, 4, 5, 6, and that's where that 6 there comes from. So you could have skipped all this if you plotted the points and then rise over run, and you would get this. So if you're going to skip this, I have to see the plotting. All right, let's talk about midpoint. So for midpoint, all we're basically going to do is average the x's and average the y's. And I prefer to use MP for midpoint because a capital M and a lowercase m look the same to me in most cases. So the midpoint is going to be an ordered pair. We're going to add the x values together and divide by 2. And we're going to add the y values together and divide by 2. So your x values are 4 and negative 2. Your y values are 3 and negative 1. So 4 plus a negative 2 is 2 divided by 2. 3 plus a negative 1 is also 2 divided by 2. And then 2 over 2 reduces to 1. So your ordered pair is 1, 1. If you do not have parentheses around an ordered pair, I will mark you off. You have got to stop being lazy and not putting parentheses around ordered pairs. So please, please, please put those parentheses around them. It makes a difference. Okay, so now we're going to look at the second or the back page, second page or back page. All right, so on this page, we're going to start with plotting the ordered pairs that you have been given. And also you need a straight edge because although, I guess I have the ability to draw a straight line, but I want to see straight lines and I want to see properly plotted points. So we're going to start with plotting these 3 points first. So 0 means nothing to the right, but up 1, so there's our A. And then I'm going to label it. Don't not label your vertices. I need to know which is A, which is B, which is C. And then 4, 4 is to the right 4 and up 4. So there's my B. And then my C is to the right 7 and up nothing. So there is point C. And so then I am going to connect them with a straight line. Okay, let's see if this works. Aha, good deal. Oh, goodness. Let's undo that one and do it again. There we go. Okay, so there's my triangle. And if you read what you're supposed to do, you're supposed to determine is it scaling, isosceles, or equilateral. It would help if you knew the definition of those words. I'm going to start with what most of you identify with. Most of you should know that an equilateral triangle has 3 congruent sides. Then an isosceles triangle has 2 congruent sides, and a scaling triangle has no congruent sides. So if you did not know that, you need to write those 3 things next to those. So if I'm going to try to determine whether these sides are congruent or not, I have to use the distance formula. You cannot use the slope formula to determine distance. That only determines whether lines are parallel or perpendicular for our purposes here. So you must use the distance formula. And I don't have perfectly vertical or perfectly horizontal lines here, so I can't just count squares. So I have no choice but to use the distance formula. So I'm going to color code it, and I'm going to use the distance formula 3 different times. So I'm going to look for, I'm going to do purple. So I'm going to find the distance, and again, you have the distance formula on that first sheet, but I have to identify which side I'm finding the distance to. Since I'm going to start with AB and work my way around, I need to note that this is the distance from A to B. So I'm going to do D sub AB, and that just means I'm finding the distance from A to B. So then I'm going to write my template. With a minus and a minus. And you could label these points x sub 1, y sub 1, x sub 2, y sub 2, but I'm going to have to keep labeling, erasing, labeling, erasing. So instead, I know that I'm always going to subtract the x's and subtract the y's. So I'm going to find the x's for point A and B, so the x's are 0 and 4. And I know that my y's are 1 and 4. And then I'm going to perform the math. So 0 minus 4 is negative 4 squared, plus 1 minus 4 is negative 3 squared, and negative 4 squared is positive 16. Negative 3 squared is 9. That equals the square root of 25, which is indeed 5. So I'm going to actually put on my picture between A and B that has a distance of 5. Now I'm going to do the distance formula again, this time from B to C. So I've got the distance from B to C, write my template, and then I am going to sub in my x's and my y's. So for B and C, so here's B and C, my x's are 4 and 7. So I have 4 and 7. And then my y's for B and C are 4 and 0. So 4 and 0. So then I get the square root of 4 minus 7 is negative 3 squared, plus 4 minus 0 is 4 squared. And then I get the square root of 9 plus 16, which is the square root of 25, which is 5. That's a 5. So then I'm going to put a 5 over here between B and C. Now at this point you might be going, oh, it's an isosceles triangle. Well, you have no idea what the length of this side is. It could be an equilateral triangle. Oh, well, it doesn't look like it. Well, you have to prove it. So we have to find the distance formula one more time. So I'm going to find the distance from A to C. I'm going to squeeze it in here. Distance, which is why I color code it, A to C. Told you I'm going to squeeze it in. Oop, that's a minus. Okay, and so then my x's for A and C, sorry, I think I said D and C, but it's A and C, are 0 and 7. So I'm going to put in a 0 and put in a 7. And then my y's from A to C are 1 and 0. So I'm going to put in a 1 and a 0. Then I'm going to do the math. So I get the square root of negative 7 squared plus 1 squared, which gives me square root of 49. 1 squared is 1, which is the square root of 50. Now, we could actually simplify the square root of 50 into 5 rad 2. However, I'm not asking you for the distance of the sides. You're using the distance to determine how many sides are congruent. So I'm perfectly happy with you leaving it unsimplified and just looking at it as rad 50. That doesn't bother me at all. And then what we're going to do is put in tick marks to show that we have only two sides congruent. And since we have only two sides congruent, this must be classified as an isosceles triangle. That's it. So it wasn't too bad. So let's look at the next one. So for this next one, I want you to start off by plotting the quadrilateral. And so I'm going to start off with, I don't know, I'll plot it in green this time. So negative 4, 3, to the left 4, up 3. So that's A. And then to the left, so negative 2, 3 would be to the left 2 and up 3. And that's B. And then C would be to the left 4, up 1. And then D is to the left 2, up 1. Connect those with straight edge. Okay. Now, as you're looking at that picture, you should be thinking, oh, it looks like a square. It's a square. Well, you have to prove it. So if you're going to prove that it's a square, you have to prove something from the rectangle, which is the square's daddy, and something from the rhombus, which is the square's mommy, because the square gets all of its characteristics, all of its DNA, if you will, half from daddy, which is rectangle, and half from mommy, which is the rhombus. So from the rhombus, it would be easy to prove all four sides congruent. And that is something that is specific to a rhombus and not a rectangle. And the reason why I say that is typically I don't choose distance unless I have to, but I have perfectly horizontal and vertical lines throughout this figure, and I just have to count. So that's what we're going to do. We're going to start off with proving all four sides congruent, because that will prove that it's a rhombus. And so if you count from C to D, I've got 1, 2. So this has a distance of 2, and I physically need to write it in to the picture, because that's how you're showing your work. So then I'm going to count 1, 2, so 2, 2, and then 2. And then on top of that, I'm going to slap somebody upside the head by saying this is equal, this is equal, this is equal, and this is equal. Because all sides are 2, therefore I conclude that all four sides are congruent. So now I've proven that at a bare minimum it's a rhombus, and that should really say rhombus, not rhombi. Then, in order to prove it's a square and not just a rhombus, I need to pull something from the rectangle. So something that a rectangle has that a rhombus doesn't is that the diagonals are congruent. Well, if I were to find the diagonals here, I'd have to use the distance formula, and I'd like to avoid that. The other thing that a rectangle has that a rhombus doesn't would be all four angles are right angles. And I can easily prove that using slope and perpendicular lines. And slope is even easier on these ones because I have horizontal and vertical lines that I should automatically know the slope to. So let's go ahead and find those. And so you have to identify which lines or which points you're finding the slope between. So I generally like to go all the way around the figure in that order. I don't want to go find the slope here and then find the slope here, because I want neighboring sides next to each other or adjacent sides next to each other, because I want to show that the slope from this side and the slope of this side are either opposites and reciprocals, or in this case, because I have vertical and horizontal lines, my slopes should be 0 and undefined to prove that those two lines are perpendicular, to then prove that I have a right angle. So I'm going to start with C to A. Well, no, let's start A to B. I'll start with A to B. It's kind of alphabetical. So I'm going to do slope sub AB, and that just means the slope from A to B. And because AB is a horizontal line, I can walk on it, it has a slope, and the slope is 0. Then I'm going to find the slope from B to D. So the slope from B to D, just Just going around the figure. Because this line B to D is vertical, I cannot walk up that line. It has a slope that is undefined. Now, I've just proven that these are perpendicular slopes, and so I'm going to state that in a minute, but it's not enough just to prove one. Please show all 4 sides slopes. So I'm going to continue around. So I'm going to go from D to C. It doesn't take much time. So from D to C or C to D. So we have this line right here, which I can walk on. So it has a slope of 0. And then this line here from C to A. And so that line, being vertical, has an undefined slope. So then what I need you to do is specifically slap somebody upside the head and say, hey, 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 those 2 slopes are perpendicular. Hey, 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 those 2 slopes are perpendicular. Hey, 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 those 2 slopes are perpendicular. We do not need to do the last with the first, because if I have 3 sets of perpendicular lines, the 4th one automatically is going to have to be perpendicular, because the angles in a quadrilateral add up to 360. And these angles right here are going to add up to 270. That only leaves 90 left. So this is not good enough, because to prove it's a square, I have to state that I have 4 right angles. So, and on top of this, we're then going to state that perpendicular lines form right angles. So in the picture, I'm going to also label my right angles. So I've got a little right angle there, 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 and there. And so because I've done that, it is definitely a square. But note that it says list all that apply. So I have to list all that apply. If it's a square, then it belongs to the rhombus and the rectangle, because that's mommy and daddy. So a square is both of these. And because it's both of these, it's also a parallelogram. So if it's a square, it's all of these. And so we have to label and list all of those. So it's a parallelogram. It's a rectangle. It's a rhombus. And most specifically, it's a square. Only because they asked you to state all that apply is the reason why we are stating all of these. If it just said to classify it, you would only state the square. Okay, let's move on to the third problem, which is this one. So again, we are going to plot our points. So I'm going to start off with, I'll do purple. All right, so -1, 4, so left 1, up 4. So I'm going to list that as P. And then A is -1, 10. So there's A. And then R is 14, 10, so to the right 14 and up 10. So that is R. And then K is to the right 14 and up 4. And then I'm going to connect with a straight line. Close enough for government work. Okay, so most of you at this point are going to be saying, oh, that's definitely a rectangle. Well, you have to set out to prove it. So you have to prove something from the parallelogram and something that makes it specifically a rectangle. So the easiest thing, I mean, we could prove for the parallelogram, we could find the slope of the lines and prove that opposite sides are parallel. That wouldn't be so hard because you have vertical and horizontal lines. So you'd have slopes that are 0 and undefined, just like we did in the previous problem. Or you could prove that you have a pair of opposite sides, both pairs of opposite sides are congruent, meaning length or distance. And normally I avoid the distance formula, but here, because I have perfectly vertical and perfectly horizontal lines, I can just count squares. And so to me, that's pretty easy. I can show that I have this pair is congruent and this pair is congruent. So I'm going to choose to do that, just to do something a little different. And then to make the rectangle special than just a regular parallelogram, you have to either prove that the diagonals are congruent, which will require the distance formula, or that you have 4 right angles, which will require the slope formula, or in our case, not even that, because I have horizontal and vertical lines. So I'm going to choose to use the slope rather than the distance formula and showing that the diagonals are congruent. So there's my reasoning behind all that. So I'm going to start off with counting my distance. So if I count from A all the way to R, you go ahead and count, but that is a distance of 15. And so from P to K, that is also a distance of 15. Then if you count from A to P, that is a distance of 6. And then from R to K is also a distance of 6. So then to slap somebody upside the head, I'm going to tell them that, see, that set of sides is congruent, and this set of sides is congruent but a different length than the other set. So that right there tells me it is a parallelogram. Then from there, I'm going to prove I have 4 right angles. So I'm going to do this in blue. So I'm going to do the slope, and remember I'm going to go around the figure. So I'm going to start from A and just go around this way. So I'm going to go from A to R. So from A to R, because from A to R is horizontal, I can walk on it. It has a slope of 0. Then from R to K, so the slope from R to K, because it's vertical and I cannot walk on it, is undefined. And right there, those 2 slopes are perpendicular. But I'm going to keep going. So then from K to P, from K to P, that's horizontal. I can walk on it. It has a slope of 0. And then finally from P to A. And then from P to A, I cannot walk on that vertical line, so it is undefined. So then from here, I have to state these 2 are perpendicular, these 2 are perpendicular, and these 2 are perpendicular. I don't have to state the 4th set is perpendicular because that's going to fall into place. Then finally, I have to tack on and add on this little piece of info. Perpendicular lines form right angles. Okay, so I've proven 2 sets of opposite sides are congruent, and I have 4 right angles, and then that right there tells me for a fact that I have a rectangle. So I'm just going to put a box around the rectangle. They did not ask me to list all that applied, but if I did list all that applied, you would do a rectangle and a parallelogram. It's not listed there, but you would do a rectangle and a parallelogram. And then if it's ever a possibility, any 4-sided figure is a quadrilateral. So you would also identify all of these 4-sided figures as quadrilaterals. Obviously, the first one we did, a triangle, would not be any of those. Okay, so then the last one that we're going to do is 2D. So we are going to plot those points. So I am going to choose purple. So A is left 3, down 3. And then B is right 1, down 6. And then C is right 5, down 3. And then D is right 1, up nothing. And we're going to connect those with a straight edge. All right, so as we look at this figure, you should be thinking to yourself, what could I prove it is? It definitely looks like it could be a rhombus or a square. You can't just prove it's a rhombus because it could be a square. So if we prove that it's just a rhombus, we also have to prove that it's not a square. Or if it's a square, we have to prove that it has something from the rhombus and something from the rectangle. So because I have a feeling it's this one or this one, I'm going to start by proving it's a rhombus. So a couple of things that you can use with proving it's a rhombus. So one of the biggest things would be to prove that all 4 sides are equal. To prove that all 4 sides are equal, you cannot use the slope formula. You have to use the distance formula. And we would physically have to use the distance formula 4 different times, which is not fun, but hey, it's not so bad. The other thing that is different about a rhombus is that the diagonals are perpendicular. So you could choose to prove the diagonals are perpendicular, which is pretty simple with slope, and then prove that you have 4 right angles. That could get you to your square if you have 4 right angles. Or you just prove that the diagonals are perpendicular and that you don't have 4 right angles, but some might try to argue with you that it could be a kite. So that I don't have to argue with somebody that it's a kite or not a kite, I'm going to actually find the distance of all 4 sides. So I'm going to start with proving it's a rhombus. So 4 distance formulas, here we come. So I'm going to start with A and move around my figure. So I'm going to go from A to B. So the distance from A to B. So you'll need some room. So again, I'm going to write my template and then sub in. So remember with the distance formula, we are finding the difference of the x's and the difference of the y's. So from A to B, my x's are -3 and 1. And then my y's for A to B are -3 and -6. So I will take care of any double negatives. So there we go. And then I'm just going to do the math. So -3 minus 1 is a -4 squared, plus a -3 plus a 6 is a +3 squared. So that gives me +16 plus 9, which is equal to square root of 25, which is a perfect square, 5. So from A to B, I'm going to put a 5 in there. All right, next I'm going to go from B to C. So the distance from B to C. I know you're moaning and groaning right now. Too bad. You can do this. All right, so my x's for B and C are 1 and 5. And my y's for B and C are -6 and -3. So take care of my double signs. So 1 minus 5 is a -4 squared, plus -6 plus 3 is a -3 squared. So that gives us square root of 16 plus 9 equals square root of 25 equals 5. So then I'm going to put a 5 on that length. Next, we are going to do from C to D. So the distance from C to D okay, so then my x's for C and D are 5 and 1. And my y's from C to D are -3 and 0. And so to do the math, -5 minus 1 is 4 squared, plus -3 minus 0 is -3 squared. So we get the square root of 16 plus 9 square root of 25 equals 5. So I'm going to put a 5 right there. And then finally, we are going to find the distance from D to A, or A to D. I guess my fingers have a different choice there. All right, so then my x values for A and D are -3 and 1. And my y values for A and D are -3 and 0. So this is equal to -3 minus 1 is -4 squared, plus -3 minus 0 is -3 squared, which equals the square root of 16 plus 9 square root of 25, which is 5. So I'm going to put a 5 right here, and then to slap people upside the head, I'm going to do tick mark, tick mark, tick mark, tick mark, and right there I have proven that all 4 sides are congruent. So at a bare minimum is currently a rhombus, not a rhombi, but a rhombus. Then to determine if it's a square, I have to figure out, do I have 4 right angles or not? All right, so that's going to require slope. So I'm going to start off with finding slope of all 4 sides. So I'm going to start with A to B, B to C, C to D, and D to A. So my slope from A to B is equal to, and I'm going to do all my rises and runs. So let's see. I'm going to list them all down here. Hopefully you wrote smaller, so then I have my slope from B to C. Because this one, you could use the slope formula, but I've already graphed it, so why do I need to use a slope formula if I can just do a rise over run? And then the slope from D to A. Okay, so if I rise from A to B, well, let's go from B to A. It doesn't matter what direction. So if I rise, I'm going to go up 1, 2, 3. That's a positive direction. And to the left, 1, 2, 3, 4. That's a negative direction. So my +3 over my -4. So that's a +3 over -4. That does not reduce. If it does reduce, you need to do so. And then from B to C, I'm going to rise up 1, 2, 3. That's positive. And run to the right 1, 2, 3, 4. That's also positive. So this slope is +3 over +4. So stop and ask yourself, are these perpendicular? Are they opposite signs? Yes. Are they reciprocals of each other? No. Since they are not, you have to state not perpendicular. So that means I do not have 4 right angles. So technically you could stop right there, but I'm going to go ahead and continue all the way around and show you what the slopes are. So I'm going to find the slope from C to D. So from C to D, I'm going to go up 1, 2, 3. That's a positive direction. To the left, 1, 2, 3, 4. That's a negative direction. So +3 over -4. And then from D to A, from here to here, I'm going to go down 1, 2, 3. That's a negative direction. To the left, 1, 2, 3, 4, also a negative direction. So down 3, to the left 4, which does reduce to 3/4. So from 4/3 to -3/4, not perpendicular. And from -3/4 to +3/4, not perpendicular. And the reason why I'm stating that is because I want to be very clear that it's a rhombus and not a square. So since it's a rhombus and not a square, I want to state that there are not 4 right angles. And I've just proven I do not have any sets of perpendicular lines, so therefore there are not 4 right angles. So therefore, it asks specifically, is it a parallelogram, a rectangle, a rhombus, or a square? And so therefore my answer is that it is only a rhombus. They did not ask me to list all that apply. So that's it. Good luck. Let me know if you have any questions.